Uh, uh, Good morning, dear students. So welcome to another session of Introduction to Data Structures and Algorithms. So in previous session, we had been through some of the recaps related to C programming. So what does C program consist of? What are the constructs which are related to C program? How you can go ahead with its analysis? What are the looping constructs? What are the decision constructs? So these all things you had gone through. What is meant by pointers, structures? So in short, we had observed this. So in coming forth sessions, we'll be utilizing those concepts and we'll be analyzing few of the programs which are pertaining to some of the algorithms, say either related to the data structures or few of the other concepts within the data structures itself. So now in this session, we'll start off with some aspects related to algorithms. So what is an algorithm? So as we have seen that we have written many of the algorithms. So in that algorithm, what we do is we try to give a overview of a solution to a given problem. So when I define algorithm, it is basically the set of instructions that define the complete solution for the problem which is at hand. So this is just a set of instructions what you will be following in order to obtain the solution to a problem. So and it basically gives you the step-by-step information pertaining to how the solution has to be implemented or how the solution has to be looked forward in order to solve the problem which is at hand. Now, what happens is there is another chance that you have a problem. The same problem can be solved in multiple ways. So, therefore, what happens is you can have multiple algorithmic solutions for the given problem. Say, for example, you want to add two numbers. Say, I want to do a plus b. Now, in general, what we can do is we can use the plus operator. We can use the plus operator. Now, in some cases, what we can do is, can we look forward for some other aspects of implementation? Say, what I'll do is I'll represent these in binary form, and in binary, how the addition goes, say bit by bit. I'll perform that operation and then go ahead with the addition. So that is another way. So for any given problem, you can have multiple solutions possible. So you can look out for those aspects. Then, when we speak in computing terms, the algorithm what we have, it gives you the information pertaining to the hierarchy of the steps. So, what are the steps which have to be followed? What is the first step? What is the next step? So, these are the things what you will be specifying. So, they will be having a hierarchy of the steps which will be utilized for computing the solution. Computing the solution, so that we obtain what output is required. So algorithm in computing terms, we can specify that it is the hierarchy of the steps which have to be followed in order to get the desired output. So that is what we can specify in terms of computing aspects. So then what are the factors which we have to look out when we are considering an algorithmic solution? So when we're considering the algorithmic solutions, these are the two aspects what we have to look forward. What is the time required for the algorithm to execute and complete its execution and obtain the solution? So that is one aspect. And what is the memory which is required for an algorithm to complete its entire execution and provide the solution? Now, whenever we talk of this, what happens is if we have an algorithm and if it is consuming a huge amount of time, if it is consuming a huge amount of time, then that algorithm might not be efficient in terms of time. And if there is an algorithm which consumes huge amount of memory, even that program or algorithm will not be efficient in terms of memory. So generally what happens is there is a trade-off between these two aspects. So if I try to adjust the time, I might be increasing the memory requirement. If I try to adjust the memory requirement, then there might be increasing the timing requirement. So these are the two aspects what we have to look out when we are considering an algorithm. So here in this part we discuss pertaining what is an algorithm. So again, it is a set of the instructions, a set of instructions which are utilized to obtain the solution to a given problem, which basically gives you the step-by-step information pertaining to how a solution has to be implemented. And we can have multiple algorithmic solutions to a given problem. And when we speak about algorithm in terms of computing terms, it gives you the information pertaining to the hierarchy of the steps that have to be followed in order to obtain the desired output. So in this, you will be specifying what you will be starting off, that is what is the input value you will be starting off, and you are looking out for the expected output. And the factors which affect the algorithm are the two aspects, that is time and memory requirement. We try to see that both are less, but there will be a trade-off when we consider these aspects. So this is say the representation of how the algorithm can be looked forward. So an algorithm, what you're providing, will have an input which is the problem to which solution has to be identified. And this algorithm will be utilized by the computer. That is, say you write a program according to this algorithm, and this computer will look forward for implementing this algorithm. So when we're implementing this algorithm, we might provide some of the inputs to this algorithm, and what is the expected output, so that will be provided by this system. So based on how the algorithm is implemented, based on what input is being provided and what is the expected output. So if you're getting the expected output for the given set of inputs using the specific algorithm, you look out for what is the time requirement and memory requirement. So to identify whether that algorithm is suitable for the solution which is being implemented. So that is what you are looking forward. Say for example, if you're driving a car and you have written an algorithm in which when you apply the brake, the pressure applied to the brakes will control the speed of the car. So if it is consuming a lot of time to when you apply the brake, and that execution takes a lot of time to apply the brakes, then it might lead to a life hazard. So we have to look into those aspects. So when we are that is just an example. Say if you're just switching on and off a light in a system in your home based on some temperature sensors, and if it is taking say 1 or 2 minutes extra, or just some 10 seconds extra, that will not create any life hazards. So that is okay. So in such this thing you can compromise on time, but in few conditions you cannot compromise on times. In few conditions you can compromise on the memory. Say life critical applications are there, their memory requirement is higher, the execution has to be faster. If there is a trade-off between these two, you can adjust as per your requirement over there. So these are a few aspects pertaining to what an algorithm is and how its implementation can go ahead. So what are the basic characteristics of an algorithm? So if we look for an algorithm, and when we are writing an algorithm, we see that there are finite number of steps specified in a given algorithm. Now I cannot have infinite number of steps which will lead to no solution at all. So I cannot have an algorithm which has infinite number of steps, and then if there are infinite number of steps, there will be no output which we can observe from the algorithm. Then here we should have the inputs specified. Whether there are any inputs to the algorithm or not has to be clearly defined. If there are either zero or more inputs which we have to look forward, so this also has to be clearly specified when we are looking forward for an algorithm. So when this is so this also defines one of the characteristics of the algorithm, that is algorithm has clearly specified how many number of inputs is required. Then when we are looking forward for implementation of an algorithm, and when we implement the algorithm, it is expected that you are operating to get some of the results. So when you are expecting a result, you are basically expecting at least one of the outputs. You might be expecting there might be more than one output also possible, but at least one valid output has to be generated by the algorithm which is under consideration. Now, apart from this, an algorithm must be definite. So, what does this imply is each of the instructions what you're providing under the algorithm should be defined clearly. That is, all the statements should be clearly specified so that it is easily understandable. So, that is what definite implies in this case. Now, it should be correct. The algorithm what you're using should be correct. That is what this specifies is uh, the algorithm should perform the task which is desired, and when it performs this task which is desired, it should be generating the output which is correct. Now if incorrect output is generated, then we have to modify the algorithm or change the algorithm. So an algorithm should be correct. This is from the point what it is from the viewpoint of the output. The output has to be correct for the given set of inputs. The algorithm should provide correct outputs for the given set of inputs by performing the steps or the tasks which are specified in the algorithm. Now, apart from this, there should not be any ambiguity in the order of the execution of the steps. That is, step two should follow step one. There should not be ambiguity whether step one should come later or whether step two should come later. So that if there is ambiguity, then it might lead to incorrect results. So even that has to be taken care in these aspects. So next, at the end, the algorithm should terminate. So basically what you are specifying is you should avoid algorithm which falls in infinite loop. So if the algorithm is falling in infinite loop, then you will not get the expected output. So it will be within the loop and output is not obtained. So these are few of the characteristics of the algorithm. So these are few of the characteristics of the algorithm, what we have to look forward. So it should have finite number of steps. It should have zero or more number of inputs. It should have a valid, say, it should have a correct output. All the instructions which are there should be defined clearly. That is, it must be definite. Then, apart from that, there should be no ambiguity in the steps which are executing. That is the order in which the execution goes ahead, and the algorithm should terminate at the end. That is, it should not fall within the infinite loop. So these are the characteristics of an algorithm. So next, what are the representations of an algorithm? So there are a few representations which are pertaining to algorithms. So in this, we can write an algorithm in English phrases. This is just for an example. Say if I want to add two numbers, so in that you can specify that add a comma b. So in that you specify the first step as the begin and the last step will be end, and within this the logic falls ahead. So and in that what you are doing is you are setting say a third parameter, set c is equal to a plus b, so which is just a English phrases what you are using in order to represent what an algorithm is implementing and what output and what inputs are being expected. So that is what you are looking forward. Then apart from that, you can use the flowcharts, which is basically the graphical representation pertaining to the implementation of the algorithm. Now, these two, what happens is these two will be useful if the algorithms are small and simple. If the algorithms fall into a complex category, that is, if you have to perform some operation wherein the algorithm leads to complexity. So in that case, we have to look forward for representing the algorithm in different form. So one of the other forms, what you can look out is the pseudocode. So pseudocode is utilized when you have an algorithm which is slightly complex in its nature and it is not small enough. That is, there are large number of steps which are involved in the execution of the algorithms. So in order to avoid that, you can go ahead with the pseudocode. Now, in this case, what is the pseudocode which we speak of? The pseudocode is nothing but the informal representation of the algorithm. So it is a false code what we can specify. This is not generally a code because we cannot execute this one. It just gives you the information, what are the inputs, what is the expected output, what are the operations which are being performed. So all this information. So which is an alternate representation of the algorithm. So you are using the informal way of representing the algorithm. It basically provides you the entire outline of the program what you are implementing. And because of the pseudocode, what happens is you can use this pseudocode and directly convert it into the programming language specifications. You can provide the statements and other aspects. So it becomes easy when you're using the pseudocode. So it gives you the complete outline of a program. Now, because it is giving you the complete outline, right, regarding the program, it can be easily understood by the programmers. So that is what pseudocode helps us. Then, apart from this, what happens is once a pseudocode is written, you can easily transform this pseudocode into a program. Say if you want to write a C program, you can use this pseudocode and convert the pseudocode into a C program. Or if you want to write a C++ program, you can convert it into a C++ program. So using any of the languages, you can write the program once a pseudocode has been implemented. Now, what happens is in this case, we basically define the structure and the syntax of the pseudocode. So, structure and the syntax in the sense you are specifying that you are adding two numbers, subtracting two numbers, you are specifying everything over there. You are declaring the variables, you are defining the variables. So, everything you are providing. So, what we do is we refer to that itself, which is indirectly somewhat similar to the programming language constructs what we are looking forward. So therefore, it becomes easy for us to convert it into one of the programs using any of the programming languages. So pseudocode is an informal way of representing the algorithm. So it is very close to the actual coding, but not exactly the same, and it is not executable. It is not executable. It is just a representation of what the program has to implement. And now, when you are writing a pseudocode, you have to follow some of the conventions which have been put forth. So, whenever you are starting to write a algorithm using a pseudocode, you should provide a valid name for that algorithm. Then, apart from that, you have to specify the line numbers which are present for each of the instructions under the pseudocode which is written for the algorithm. Then we should provide the information pertaining to the identifiers. Say if you are using the index, so you can put some indication that a variable is identifying a index value. So you can use the name as index. You can specify it as index. So which gives me the identification that this variable holds information pertaining to a index. Now, in this case, what happens is since we are just writing the pseudocode, no need to specify what data type it is. But as we write the program, at there it becomes more clear which data type should be index. So I'm just specifying the index. What data type I'm not specifying over here. But when I'm utilizing it, when I'm converting this pseudocode to the actual program, so that time I specify what data type this index should be. So that is what we are looking forward. So then we should always indent the statements which are present inside a block structure appropriately. So indenting is what, so here you can see that in this case, if you just observe, so what you have done, you have written the if statement and next you have put the statement. So here you can see that there is say a tab space. So this is what is called indenting. Now here you can observe that there is a for loop and within the braces you have the statements. So here you have what you have done. All the statements are written after a tab space. So this is indentation. So what this does is even if you don't have indentation, it is not a problem. But what this does is it helps me to read the pseudocode or the code easily. It helps me to understand that okay, these statements belong are within these two braces. So this is one of the major advantages when you write the programming in some indented form. So if you don't write an indented form, you have to search. So if there are, imagine if there are multiple for loops, so which brace is for which for loop, it becomes difficult. So if you provide it in some proper form, then it becomes easy for us to go ahead. So if you have to just observe a code, right? So here I have written it. So here you can see that in this case, what you have a for loop. Within this, another for loop is there, and within this, the print statements and another for loop. So, imagine that if I don't indent this, here it is a small code, it is not a problem. So if I don't indent this properly, then you can imagine what might be the problem over here. Okay. So we have to keep track. So this one, which is the closing brace for this loop, this for loop. For this one, which is the closing brace. So here I can make out. So I have to keep track of these aspects. So when I'm looking for indentation, okay. So that is what this aspect means. That is, indent the statements properly. So that reading of the program or the pseudocode becomes easy. And use the read write instructions at appropriate points. So if you're taking an input, you have to use the read instruction, and if you're say representing an output, you can use the write statement. So that is, you make use of these as, say, a keywords over there, not exactly the keywords, but keywords for the pseudocode. So read, say, element A, and read element B, and write A plus B. So that is what you are looking forward in this case. Then if there are conditional constructs, right, or conditional statements, you can use the if or the if else constructs in these cases. So how you go ahead, you can use only the if construct in this way. If you just observe, you have if within the brackets, you are specifying the conditional expression, and within this you have the statements, and the if statement has to be terminated by the end if. You have to provide an end if statement for termination of the if statement. Now, if you're using if else, so what you can specify is if within this the conditional expression and the statements which are indented. So in this case, since it is a pseudocode, no need to provide the braces. The indents will work, that will tell us that these are the statements which fall within the if statement, or else you can, for your convenience, you can put even the braces over there. So then after if you have a else, you put the else statement, and else this thing keyword, and then provide the statements which fall under the else block. And again, if you just see, when you're using the if, this should end with end if statement. It should end with end if statement. And if you just observe, the alignment is vertical. Alignment is vertical. So that is what this specifies. You should have an end if statement for both. That is, whether you are just using the if statement or if else statement. And these are vertically arranged. That is what you are specifying here. Then again, if you have looping constructs or the iterative constructs, right? And for those cases, you can use the for or the while looping constructs. So you are using for and while as a keywords in the pseudocode. So what you are specifying is, you can see here, for what range of I. So I in the range of 1 to 10. What you have to do, you have to execute these statements. So based on what conditions, even that also you can put forth over there. So this is just a simple this thing. And whenever you are using a for loop, right, a for construct, right, you have to use a end for to identify that the for loop has ended over here. So you have to use this indicator for indicating the end of the for loop. Similarly, when for while loop, what you can do is, you can use the while this thing construct over here, and then specify the conditional expression and perform the execution of these statements based on the condition. And this while this thing has to be terminated with end while. So which gives us an indication that this while is been ending within these statements. Only these statements belong to this while loop. Similarly, for and for, whatever statements fall within this will be under the for loop. So that is what we are specifying over here. You should have a end for statement and end while statement. Now, whenever you are performing the operations, you might require some of the logical and relational operators to be looked forward. So say you are checking the condition over there. So if you're checking the conditions, then you can make use of the operators. So previously we had studied some operators. We can use those operators directly. Say I want to compare whether I is less than equal to j. So this is how I can go ahead. But when you're implementing it in code, right? How you write? You write it as less than equal to j. You write it in this form. This is the actual code. This is just for representing the pseudo. Okay, so this is how you are looking forward. So if you're using the logical and relational operators, you can utilize those relational operators in the conditional aspects. So here these are the aspects what you can look out for. You're checking whether I is equal to j, whether I is less than j, whether I is greater equal to j. So these are the relational operators what you are looking forward. And lastly, when you're representing the array, or say a list of elements, say if it is a structure, then it becomes a list of the elements. Then how do I look forward for representing that array? So I have to specify the name for the array, and I have to make use of index to identify a specific element within the array. So how do I specify that? I give the name of the array. So in this case, you can see that we have A, which is the name of the array, and I is the index which we are utilizing. And this index has to be written within the square brackets. Has to be written within the square bracket. So what is this representing? This is representing the ith element within the array, which is named as A. So these are few things what we have to follow when we are writing a pseudocode. So provide valid name to a pseudocode or the algorithm, then specify the line number so that it becomes easy for us to keep track of the different aspects in that. Then provide the identifier names, which are nothing but the variables what you are using. So specify proper names so that it becomes easy for the programmer or the analyzer to read it. Then you use the indentation so that reading can become easy. That is, you provide proper tab spaces wherever required to say I want to identify that these are the statements which fall within this. So instead of, if there are multiple for loops, then what happens? You have multiple end for. So it becomes difficult to track which for and which end for are falling and which statements are falling within which for loop. So that is one example I showed in the C programming construct over there. So if you keep indenting, right, it becomes easy for us to keep track of those aspects. Then if you're using if and else statement, and if has to be utilized, and if you're using for, you have to use the end for statement. If you're using while, you have to use the end while statement. Then you can utilize the different relational and logical operators within the pseudocode. Then lastly, how do you represent the array? You represent the array with the help with the name of the array along with the index. So if you want to specify one particular value within the array, then you can utilize its index over there. So that these are few aspects which you have to follow when you are writing a pseudocode. So in this, we can observe write an algorithm to interchange two numbers. So again, as I specified, so whatever we have discussed here, right? So indirectly we are writing the algorithm itself, but in pseudocode form. So here, what we have mentioned the steps. We have mentioned the steps. This is one of the things, and we have the identifiers over here, and we have a name which is given to the pseudocode or the algorithm. So the name is interchange x y. So this is giving an indication that there is some interchange of the values between the variables or the identifiers x and y, and the steps are properly specified. And within these two, begin and end, you have the entire things specified. So in step 2, what you are doing is you are setting, that is you are initializing this value x with x plus y. And in the next statement, what you're doing, you're setting y with x minus y. And lastly, what you're doing is x is equal to x minus y. And results you have to display it. So these are the x and y are the inputs, and x and y only are the outputs. So in order to provide that output, what you're doing, you are using the write statement. So you are write these two onto the output console. So this is just a pseudocode. You're not specifying which data type it is, nothing. You're not specifying anything. You're just giving the logical implementation of how it goes around. So here, this is one way of how interchange has been done. So if you want, you can have another temporary variable where you can specify as set t is equal to 0. In this, what you can do is you can again write set t is equal to x. So x value is stored in this one. Next, you can write set x is equal to y. So now what you can do is set y is equal to t. So indirectly you have exchanged x and y even in this form. Now, apart from this, in this case, what he has done is without using a temporary variable, he has interchanged the values of x and y. So if you just consider, say, x is equal to 1, x is equal to 1 and y is equal to 2. So I want to interchange. So at the starting, these are the values, x is equal to 1 and y is equal to 2. So when I add both the numbers, what I am having 3 in x. That is after step 2 is executed, x is equal to 3. And after this step, that is it is 3 minus 2. 3 minus 2, which is 1. So 1 is stored in y. Now in this step, what is 3? Sorry, what is x? X is 3. So it is 3, new value of y is 1. 3 minus 1 is what? It is 2. So here we can see that in this case, y is equal to 1, and after this step, x is equal to 2. So here you can see that at the initial stage, x is equal to 1 and y is equal to 2. In these two stages, if you just see, both the values are interchanged. So without using a temporary variable, they have interchanged the values of x and y. So this is just an example what we have considered. So these are a few other examples. In this, you are finding the average of the numbers. So here you can see that what changes are there. You have given the name, you have given the say identifiers in which average and sum is being utilized, and you have provided the details of the steps. And then here you have specified the begin and end for this pseudocode. Then what you are doing is you are initializing the average and the sum values to 0. So here what you're doing for I is equal to 1 to 10. So here you can put the indent. They haven't put the indent over here. Since it is just one line, it will not be a problem. But what you do is you have to provide sorry, these two statements are there. You can put an indent to identify that these two statements belong to this. So since only one for loop is there, it will not create problem. When multiple for loops come, that is for loop within a for loop, that time you use the indenting. So here for I is equal to 1 to 15. So for I in this range, what you're doing is you're reading all the 15 elements. Once you're reading all the 15 elements, what you're doing is you are adding the elements one by one and storing it in the sum value. And this is the end for. So this part is executed until I becomes 15. So 15 elements are added, their sum is calculated. And at the end, what you're doing is you are taking the average, which is sum divided by the 15 numbers what you have read. And you have to display, or this is the output what you will be providing. So write average. So write statement you are using and providing it to the screen. So this is pertaining to another algorithm. Similarly, you have another algorithm in this case. So in this one, what you're doing is you have used the if construct. So here you can see that two for loops are there. So since only a few number of steps are there, it will not create problem, but better go for indentation if it is required. Okay. So if you can go for indenting, proper indenting. Even this is also indented. In this case, you are not using the tab space, but in the previous, I was just showing that you can use the tab space to make the difference. Okay. So you can utilize without this or with tab spaces. With tab is better, so that it gives you the direct indication that which statements fall within the for loops and which end for is for which for construct over here. Okay. So next, how do you define the efficiency of an algorithm? So there are two major things. So what we have to look out when we are dealing with the efficiency, that is one is time complexity and the other one is space complexity. As we had specified that one of the characteristics of the algorithm is the requirement for the time and the requirement for the memory space. So those two itself gives us the indication regarding how efficient an algorithm is. So here, efficiency of an algorithm is basically defined based on how much time the algorithm takes to execute and how much memory it takes to execute the algorithm and obtain the results. So in this case, what we are doing is we might be giving a set of input to the algorithm. Once we have given the set of inputs, we try to compute how much time the algorithm will take to provide the expected output. And similarly, we also try to measure how much memory requirement is there for the algorithm to complete its execution and provide the result. Now, these two in turn give rise to what we call as time complexity and space complexity. Now, what is basically time complexity? In this case, you can observe that time complexity is basically the measurement pertaining to the running time of an algorithm. So, for how long an algorithm will run to provide the expected output. And when we are dealing with this, with the given set of inputs, we are providing some inputs to the algorithm and we are seeing how long or how much time does the algorithm take to complete its execution. So that measure itself gives us the time complexity. Now, how is the time complexity obtained with respect to an algorithm? So here we can observe that here you can see that there are 6 steps, there are 9 steps, there are 10 steps, and there might be the looping constructs. So all these things, when we consider, right, these steps what we are specifying indirectly give us the indication of the time complexity. So if I'm able to count these primitive or elementary steps which we are performing to obtain the results from the algorithm or obtain the outputs from the algorithm, so that steps or the primitive steps or the elementary steps gives us the information pertaining to time complexity. And here if you just observe these all steps what we are specifying, these are all machine independent. So these steps are same in whichever system you want to implement it. So here if you just see here we require 6 steps to complete, so which will give, say for example, it will give me a time complexity of, say just as an example, 6. But when we consider the for looping, right, it will be slightly different. So how many steps will be involved in its in its execution, that is what we look forward. So in any system, when I consider these steps will be same. So here we obtain the time complexity by counting the primitive or elementary steps which are required to complete the execution of the algorithm, and these the time complexity is machine independent. It is machine independent. But what happens is it basically depends on how many input data you are providing. That is, what is the size of the input data. So here, if you just see here, we are just providing 2 inputs, and say the size of these is just one byte. So based on that, the execution goes ahead. But here you can see that you are accepting 15 inputs. So this will consume more amount of time. So that is a total of 15. Say if 1 byte each, you are providing how much? Total of 15 bytes. The size of the input data is around 15 bytes what you're providing for that second case. So this is regarding the time complexity. Next is the space complexity. Now space complexity is pertaining to the memory space requirement. So in this case, what you do is you try to measure the amount of memory which is required for the algorithm to complete its execution. And when you're looking forward to this, you are looking forward to provide a given set of inputs. So for a given set of inputs, how much amount of memory does the algorithm consume? Memory does the algorithm consume to complete its execution? That information gives you the space complexity. Now, lastly, what is meant by the algorithm complexity? So this is nothing but time complexity and space complexity combined together. So algorithm complexity is basically a function. It's basically a function that helps you to obtain the time complexity information, that is the running time of an algorithm, and space complexity information, that is nothing but the memory space requirement of an algorithm for a given set of inputs. So algorithm complexity is the function which helps us to identify the time complexity and space complexity for a given set of inputs. So if I put forth in a different form, it's a function which obtains the running time of the algorithm and the memory space requirement of an algorithm for a given set of inputs. So that is what algorithm complexity defines. So this is